Hi and welcome. We're looking at 7-3 similar triangles. We're going to be doing some practice in our study guides. We've got three ways to show that triangles are similar. We can use two pairs of angles that are congruent to show that angles are similar. We can show that three sides, all of the corresponding sides of these two triangles are proportional to each other. Or we can use two pairs of sides being proportional and the angle in between them being congruent. Let's look at number one on our study guide. Number one on our study guide shows us two triangles, and it has this angle marked congruent to this angle, and angle B marked congruent to angle E. Now I have two pairs of angles being congruent and no other information, and so we can state that these triangles are indeed similar using the angle-angle similarity. Now we have to write a similarity statement, and so we'd write that as triangle ABC, that's the name of this first triangle, and the symbol for is similar to is a single tilde, then triangle, and we need to do corresponding parts. So angle A corresponds to angle D, angle B corresponds to angle E, and C corresponds to F. And so that would be my first similarity statement. Here we're looking at number two. We're trying to decide if in fact these two are similar. I know that I have congruent angles in here because both of these are right angles. The question remains, are the sides on either side of the angle in proportion? That is, I can write them as fractions, and those fractions are then equal. I'm going to have this side be related to this side because they're both the smaller numbers. So 18 over 20, and if I reduce that down, I'm going to get 9 over 10. I'm going to look at the other pair of sides. I'm going to look at this side and this side. And again, I'm going to write the smaller number over the larger number, and I'm going to reduce that down. They're both divisible by 3, and I'll get 8 over 12. Ooh, I can divide that again by 4. I'm going to get 2 over 3. These two fractions are not the same. That means that these two triangles are not in proportion, and so these triangles are not similar. Here's number 3. I'm looking at these two triangles. I have the triangle here colored in green, which is triangle STL. And then I'm looking at this other triangle that I'm going to color in red, RTU. And the question is are those two triangles similar? Yes or no? I do have some parallel lines going on here, so I can make use of parallel lines and a transversal. So if I extend these lines a little bit, I'm able to more clearly see the parallel lines in the transversal, which means that these two angles right here are what are called corresponding angles. If we recall, our corresponding angles postulates allows us to say that corresponding angles are congruent when the transversal is passing through parallel lines. And so I know that angle R is congruent to angle S by the corresponding angles postulate. I'm going to abbreviate there. Now I also have already given to me that angle T is congruent to itself because that angle is the same angle in the green triangle as it is with the red triangle. So since I have two pairs of congruent angles, I'm allowed to then use the angle-angle similarity in order to say that these two triangles, triangle STL and triangle RTU, are similar. The rest of the ones on this study guide are going to follow much the same format, so I'll let you continue practicing those on your own. I'd like to take a moment then to flip the page and look at some of these items on the back side. We're going to identify similar triangles and then find each measure. This first one wants us to find the measure of JL, and so I'm going to highlight it in yellow. There's the measure of JL. That's the side that they want us to locate. Now, I could use right triangles, but I haven't learned right triangles yet. We're still dealing with similar. And with similar triangles, knowing that here we have two pairs of angles congruent to each other, we can say that these angles and these angles are in proportion. So I'm going to go ahead and set that up now. You're going to see me change colors so that way you can more closely identify which item I'm putting where. All right, I'm going to say that this angle, or excuse me, this segment KL is in some sort of relation with this other side JL, and that fraction, because these sides are similar, is equal to the fraction I get when I take YZ and I put it in a fraction over XZ. All right, let's go ahead and fill in the information we know. KL has a measure of 20. JL has a measure of, I'm not really sure. I'm going to write it as an X. Just going to change the color here because I'm realizing that that yellow is a little too pale and hard to read. YZ has a measure of 10. And XZ has a measure of 13. Now, whenever I have one fraction equal one fraction, I can cross multiply. So cross multiplying is going to give me 13 times 20. 13 times 20 is 260. And then I'm going to have on the other side 10x. I'm going to divide both sides by 10 because I'm trying to get x by itself. And when I finish that division, I will have x with a value of 26. Now, I wasn't looking for the value of 26. I was actually looking for the value of JL. But JL has a measure of x, and so my x value is 26. Looking at number 3, right under it, it looks a little tricky because we have this square root thing, but all of the concepts are exactly the same. Now notice how I have this side here, 36, and this side here is 36. I'm trying to figure out what the measure of this side is right here, QR, and it's also labeled as my variable x. Now, I don't know if these two are parallel or not. Assuming that they're parallel, I can see that this side is going to be equal to this side because the entire lengths are the same. And if this is parallel, it's going to hit in the same sort of spots. So let's go ahead and see if we can't figure out when it is parallel. 36 minus 24 is going to give us 12. I just subtracted off so that I could figure out what this measure is. And assuming that this was indeed parallel here, I can say that. If it's not, I'm going to have to use a slightly different method related to what was up here in order to do that, but I'm showing you the little shortcuts. I want to take a second to look now at number 4, which is letter B. It definitely looks way more complicated. There's a lot going on, but I have some parallel sides happening. Because I have some parallel sides, I'm allowed to say that this angle is congruent to this angle. I have these two as vertical angles being congruent. These two are alternate interior, and so I know for sure that these are similar triangles. Because they're similar triangles, I can start figuring out what the value of this one is. In order to find that out, I want to know what side corresponds to this one. That is going to be, because we have alternate interior, it's going to make it this side that corresponds with x. And so I can set up my fraction as x over 38.6. I need another pair of sides to set this equal to, and I notice I have information about my parallel sides. 30, and 60. Let's start with the small one on top because I started with the small triangle on top on the other fraction. And this is 30 over 60. I'm going to make some multiplication a little easier for myself by reducing this right-hand side. I'm getting rid of a 10 in there. And so my new fractions are going to be x over 38.6 equals, I'm going to go ahead and reduce this also, 1 over 2. That's going to make some of my multiplication a little easier. Cross multiplying, I'm going to get 2 times x equals 38.6. And now a simple division by 2 is all that's needed, and x will end up equaling, oh my goodness, time for me to grab my calculator because I am not very good at the whole multiplying stuff in my head. My calculator tells me that this is 19.3. All right, those are some of the examples that can help you on 7-3. Hopefully this helped you out, and we'll see you later.